Okay, for this final video, we're going to be looking at just two problems, and they are kind of the trickiest ones, so I thought we should practice those and then you can try them a little bit more too. So notice that it's actually a simple equation to solve, but inside of the trig function, there is more than just a theta. Okay, so sometimes a little bit more, sometimes a lot more than a theta. So this is when we're going to use that U substitution technique that we did in class. So just a couple more examples of that process. Okay, so we're going to call this tangent of U minus 1 is equal to 0. Notice that we're making U equal to 2 theta. Quick note, obviously we do have a double angle formula for tangent. If you look at the double angle formula for tangent, it really just makes the problem a lot more complicated. So I think you would probably not want to use it because it would be really hard to then solve the problem. So it wouldn't really get you anywhere if you did try that. Okay. So instead, let's just use a U substitution. So we get tangent of U, we're going to add 1 is equal to 1. And so now we do find what angles make tangent 1, right? So for tangent to be positive, we must be in quad 1 or quad 3. And then tangent is 1 when the two sides of the triangle are equal. That's that 1, 1 root 2 triangle. That is the reference 45 or pi over 4 triangle. So so U would be pi over 4, or in the third quadrant, that would be what, 5 pi over 4? But notice that I don't need to write that one. I could just do my general solution plus pi k. Okay? Now, for these problems, when you've made a U substitution, you have to do the general solution, the general formula. You can't just do the solutions to begin with. You have to do the general formula first. Okay, so next, after we find what U is equal to, we substitute back in for theta. So we do 2 theta is equal to pi over 4 plus pi k. Okay, so U is equal to 2 theta. So resubstitute that back in. And now you can see that we need to divide both sides of the equation by 2 in order to solve for theta. Okay, we're not supposed to solve for U. We're supposed to solve eventually for theta. So pi over 4 divided by 2 is pi over 8. And then this would just be like pi over 2 times k. Okay, so this is theta. This is the general solution. If they ask you for the general solution, you're done. Yay. If they want all the solutions in 0 to 2 pi, then you have to start seeing, well, what if k equals 0? What if k equals 1, 2, 3, and keep going? So we're going to do that next. So let's say that k is equal to 0. Okay, well then theta would just be pi over 8. So theta equals pi over 8. And see, that is in the circle 0 to 2 pi. So that's one of our answers. If k is equal to 1, then theta would be equal to pi over 8 plus pi over 2, and that's times 1, so that's just pi over 2. So pi over 8 plus pi over 2, let's see, that would be 4 pi over 8, so it would be a total of 5 pi over 8. Okay, 5 pi over 8, that's more than pi over 2, obviously, so it's in quad 2, so that is a good answer. So we have to keep going. K is equal to 2. Theta would be pi over 8 plus, and then we want to do pi over 2 times 2. So that would actually equal pi. So pi over 8 plus pi. So that would be like 8 pi over 8. So 9 pi over 8. I'm kind of just adding these fractions in my head. You are welcome to use your calculator. Again, don't type in pi. You just do like 1/8 plus 1. And it will give you 9/8 if you turn it back into a fraction. Okay. So 9 pi over 8, that's in quadrant 3, right? It's just a little bit past pi. So we have to keep going. Okay. So if k is equal to 3, then theta is equal to pi over 8 plus 3 pi over 2. And let's see, that would be equal to, let's see, 12, 13, I think. 13 pi over 8. Let's see, that would be times 4, so 12 plus 1. Yep, 13 pi over 8. Now, 13 pi over 8 is less than 2, right? Because that would be 16, so that one's good. But I am in quad 4, so if I add on any more 90 degrees or pi over 2's, I will be out. So k equal to 4. You can try it, but it's going to be too big. Okay, so you're done. These are your answers to the solutions that are between 0 and 2 pi. So as you can see, like these problems are a lot of work and a little tricky, right? So let's do one more together and hopefully we will get it. Okay, so this is a very complicated setup for our cosine, so we're going to make that into a u. So u is equal to theta over 3 minus pi over 12. And then we're going to just solve for u. So cos u is equal to a half. Okay, fantastic. I know that u is equal to a half. I'm going to stick it over here. Let's see, in quadrant 1, obviously. And then it's also positive in quadrant 4. And then if it's 1 there and 2, then that is the 60-degree reference angle. So it's a pi over 3. So I've got pi over 3 plus 2 pi k. And then I also have, let's see, what is that? 5 pi over 3 plus 2 pi k. Okay. So I do need to write both of those because there's not a way to get around to the other one. So unfortunately, I have these two answers for u. Okay. So now I have to take u and put all this back in for u. So I have to go, and I'm going to have to do this twice. Not a super fun one, a lot of work. So theta over 3 minus pi over 12 is equal to pi over 3 plus 2 pi k. Okay. So I need to solve for theta. So the first thing I'm going to do is add pi over 12 to both sides. Okay, I'm going to add it to pi over 3 because those are like terms there. So theta over 3 is equal to, let's see, that's 12 times 4, 4, 5. I think 5 pi over 12. Okay, so let's see. And I'll just double check that that's right. I need to multiply by 4 to get the denominator 12. So that's 4 plus 1, 5. Yeah, I'm happy with that. And then I'm still adding 2 pi k. All right, and then I'm going to take this and I'm going to multiply both sides by 3 to be able to get the theta by itself. Multiply this side by 3 as well. So theta is equal to, 5 pi over 4 plus, and then be careful because you do multiply this as well, 6 pi k. Okay, so this is one of the general solutions. Happy, happy. If it's just asking for a general solution, you know, I'm most of the way there. If I'm asking with for the k's, then I have to start plugging in. Okay, so let's just do that there for that one for this one. So if k is equal to 0, right, then theta would be equal to 5 pi over 4. Okay, now think about that. 5 pi over 4 is already in quadrant 3, right? So if k is equal to 1, that's 6 pi. That's just too big. That's way out of what we want. So here is my only solution for that part of the problem, just 5 pi over 4. All right, now I do need to do this other piece. So I also had 5 pi over 3 here, right, in quadrant 4 to start with. So I'm going to solve that one too. So I've got theta over 3 minus pi over 12 is equal to pi over 3 plus 2 pi k. I was doing so many things, I feel like I forgot what I was doing. I'm just taking the u out of the equation and substituting in what u is equal to. All right, so now I need to add pi over 12 to each side. sorry, I thought I said this. Sorry about that. 5 pi over 3. That's this one. I'm doing the second problem. I'm not going to do this one again. Oof, okay. Pi over 12. All right, so I get theta over 3 is equal to, and then let's see, with the denominator 12, that's 21. 21 pi over 12 plus 2 pi k. Okay, and then I'm going to have to multiply both sides by 3 in order to get theta by itself. So theta is equal to 21 pi over 4 plus 2 pi k. Oh, not 2, 6. Sorry, this video is going on too long and I'm getting tired. Okay, 6 pi k though, right? Because 2 times 3. All right, now this is our general solution. We are happy with it, right? But is 21 pi over 4 even in 0 to 2 pi? No, no, it is not, right? If we divided by 21 by 4, we would get 5 pi and something. So there is no solution in the unit circle. So the only solution to the problem that is between 0 and 2 pi is this 5 pi over 4. And then the general solutions still stand for both of them. All right, well, we better wrap that up before I make any more silly errors. So I hope this has been helpful, and I hope it helps you to solve all of the rest of the problems and figure out this section.